Bismillahirrahmanirrahim. Let's continue, inshallah. Question number 31. Two hoses are used to fill the pool. So we're still talking about the same pool. And they're filling it with water. So there's like water, hose 1 and hose 2. Twice as many gallons of water per minute flow through one of the hoses as the other one. So like one is like a big hose, and the other one, it's not as big of a hose. So if the rate here is x, the rate here is like 2x. Okay. Alright, so twice as many. Both hoses had been on for 12 hours and had filled the pool to 4-foot mark when the hose with the faster flow rate stopped working. So the faster one, kind of gave out, stopped working. The hose with the slower flow then finished filling the pool to the 5-foot mark. Which of the following graphs shows the relationship between the time spent filling the pool and the height of the water in the pool? Okay, so here's the graphs given. So what happened is they were filling, right? Both of them. So the rate of filling, the rate of change would be higher in the beginning, and then one of them broke. And then you're still filling. The rate of change, however, is small. That's what slope is. Slope is the rate of change. So we're looking for a graph basically that looks like this. Fast filling, right, in the height over here, and this is time. And then slowing down. So that's not it. That's what the heck, that's not it. And that's not it, just this linear change. That's not it. So, this is it. See, this is very fast rate. So compared to over here, the rate of change is slower. And that's the slope. Slope is the rate of change, and this is the when both were working. So this accurately represents what happened there. The rate of change, both working is faster than over here. The rate of change is slow. 32. The directions for assembling the pool state that the ladder should be placed at an angle 75 degrees relative to the level of the ground. Which one of the following expressions involving tangent gives the distance in feet that the bottom of the ladder should be placed? So here's the ladder, here's the pool, okay? So here's the ladder that's over here, okay? And this angle is 75 degrees, and this is the right triangle. So which one of these expressions accurately represents the distance that the ladder has to be from the pool? Let's call that x distance. And we know this is like 6 feet, okay? So, well, what ratio do we have over here? Is opposite and adjacent. So that's tangent. So tangent of 75 degrees is opposite over adjacent, okay? And then, now we have to solve this for x. So it's like which one of these represents this distance? So you solve this for x, you get x times tangent of 75 equals 6. X equals 6 over tangent of 75. So that's actually, let me give you the PDF version actually. X, what do I have here? 6 over tangent of 75. That's F over here, see? 6 over tangent of 75. That's what this is saying. So that's this over here at 6 over tangent of 75. I just want to bring to attention one thing over here, okay? When we had this tangent of 75 equals 6 over x, okay? The way you solve this equation, of course, you can cross multiply, because like that, okay? You can cross multiply. It says tangent of 75, okay? X times tangent of 75 equals 6 times 1 is 6, and then divide both sides by tangent of 75. You get 6 over tangent of 75 like that. Okay, that's perfectly alright. But one quick way is, there's some things you gotta know. For example, x, if you have two ratios over this, a over b, see, there's some things that you can do to these in this scenario that are legitimate. That is, for example, you can switch these two values and you'll be okay. So it'll be b over y equals a over x. So this is a perfectly legitimate thing to do. If you are given two fractions like this, you can switch these two values. For example, 1/2 equals 4 over 8. That's true, isn't it? Correct? I can switch the 1 and an 8 and still be true. See? 4 over 1. I have switched these two values here, and then I get the same equivalent fractions. So when you're given fractions like this, okay, it's very legitimate to switch these two values, okay? These are shortcuts, so it becomes b over y equals a over, okay, over x. So this is perfectly legitimate thing to do. You can switch these also, you know, that's perfectly right. And the other thing you can do is you can switch the whole fraction, okay? So you can flip the whole thing, both sides. You know, you can't just do one side. So it becomes y over x equals b over a, okay? You can do that. Now, why is this important? See, because we had tangent of 75 equals 6 over x, okay? This is like the same scenario, x over y equals a over b. To solve this, in my mind, I just switch these around. X equals 6 over tangent of 75, and that was the answer. So, you know, it saves you one step, you know, and this is like basic algebraic manipulations that you got to know. So that's very important. So that's number 32. Number 33 is this question. Didn't come out very well in the word format, so I'm going to read it here. For a population that grows at a constant rate of r% per year, the formula P of t equals P0 1 plus r over 100 all to the exponent of t models the population t years after initial population of P0 people is counted. The population of city of San Jose was this much in 1990. Assuming that the population growth at a constant rate of 5% per year. According to the formula, okay, so that's the growth, okay, that's the initial population. According to the formula, which of the following is an expression of the population in the year 2000? Oops, okay, so those are the key terms, all right. So what this formula is, it tells you what the population is going to be for the city given a certain time, okay? So in this formula, P0 is the initial population of the city, which is here, this. Rate, R, is the rate of change of the population, which is 5% in this case. T is the time, okay? So if you have that, okay, then the population, okay, after 10 years, going from 1990 to 2000, T is 10, see? That's going to be the initial population, which was 782, 1 plus the rate, which is 5%, okay, 501, which is 0.05. See, that's this here, maybe I shouldn't go too fast here, is 5 over 100 to the exponent of t, which is in this case 10. This is 782,000 plus 1 plus 0.05 to 10. And that is 782,000 to the 10. And that's this. Okay? So the answer is this. Now this question is very easy if you know this formula. If you know this formula. And that formula is the formula for exponential growth. And if you did Algebra 2, you would have encountered that. Or perhaps even in Algebra Adventures otherwise. So we have learned, for example, this is important. This is compound interest. It's very similar to compound interest. They might have a question like this. Compound interest, if somebody puts some money in their bank, the formula for that is this. Okay? Okay. So in this compound interest formula, A is the amount of money somebody has in the bank. Let's say if somebody puts like $100 in the bank and the interest rate is 5%, okay? A is the amount of money they'll have after 2 years, 3 years, 4 years, 5 years, whatever T is going to be. A is the amount of money a person has after a certain amount of time T. P is the initial amount, okay? Rate here is the interest rate, okay? And N is how often the interest is calculated, and T is the time. So this formula is very similar to compound interest formula. If somebody put $100 in the bank at that rate, this formula would be 100 plus 1 plus 5. If it's compounded, let's say once a year, that would be 1 to the T, that 5%, which is that, okay? So this formula will simplify to 1.05 to the T like that. So this is a compound interest formula. Now what this question is about exponential growth, and compound interest is just one example of exponential growth. Exponential growth formulas, they look like this, okay? Y equals, okay, something, the initial value, you can call it A, 1 plus the rate to the exponent T, okay? An exponential decay formula, see, they go like this, 1 minus R to the exponent T. This is the growth rate, and this is like the decay rate. So if, for example, if the bacteria are growing in a petri dish, they're growing in an exponential rate, and that would be their growth rate. If, for example, carbon-14 is decaying, or something's decaying, or it's decreasing in its value, this would be the rate of decay. Both of these formulas are very similar if you appreciate. The only difference is if it's growth, then the rate will be added. That's how much you're adding to the growth. If it's decay, the rate is subtracted, because that's how much you're subtracting from the growth. So this formula that's given to us of this population at a certain time is based on the initial population plus 1 plus the rate of growth at to a certain time, which is this formula over here. Okay, so in this case, the initial population was 782,000. 1 plus the rate is in percentage, but if you put it as a percent, that's going to be this to the time. Okay, and this simplifies to 1.05 to the time. So this is the population of the city at any given time is growing at this rate. Okay, so this question is difficult if you don't know this whole concept, and it's easy if you do. And I hope that you appreciate that a little bit. This question, on the other hand, number 34, is a gigantic waste of time. Probably not, but I'm just saying it's a pain. But anyway, let's read it. Tom's long-distance service charges him 10 cents per minute. So from 7 p.m., if he's just patient and call people at night time, from 7 p.m., it is going to charge him this much, okay? It's on all weekdays and all Saturdays and all holidays. Okay, so this is for weekdays. And for Saturday and for holidays, okay? That's how much this charges for that. Okay, for all holidays. And then, and it charges them this much. There are some weird companies. It charges 5 cents per minute on all Sundays. Okay. And then it charges them 25 cents. Okay, 0.25 on all other time. Okay, everything, all other times. Okay, so let's see. This guy likes to make phone calls. Okay, so we're asked to basically find here in this how much. This is the phone calls he made, and how much money did the phone company collect from him, making his life so complicated, making him do all calculations. Whoever remembers this, what their phone company charges at certain times. I mean, it's okay. Anyways, that's what they do anyways. So 7 p.m. to 7 a.m. So they made one call. He made one call Tuesday at 5 p.m. Well, where is that going to fall? That's not this. And that's not Sunday. That's going to be 25. So this is going to be 0.25. That's the rate there. Wednesday at 10:30 a.m. That's not this. It's not 7 p.m. to 7 a.m. That's not a Sunday. That's also going to be 0.25. That's the rate of charge for that, the 25 cents. And Thursday, Thanksgiving, that's a holiday. Doesn't matter what time. That's going to be at this rate, 0.1. That's 10 cents, okay? And then on a Saturday, which okay, all day Saturday, that's this rate, 0.1. And the Sunday's rate is the cheapest rate. So you should wait to make all these calls on Sundays, right? Okay, so okay, now we are supposed to tally up, okay? So he did this much, all right? So this is how many minutes he has. So, but you notice over here, these two are the same rate. These two are the same rate, and this one is different. So he gets 18 minutes, okay, at that 25 cents, 0.25. Plus he gets 32 minutes at this rate, 0.1. And then you have to add to that 22 minutes. He does talk for quite a bit of time on Sundays because he knows it's cheap. Anyways, 22 minutes at 0.05, okay? So this is the total amount of money he's going to have to pay. So you do this and do this and do this. If you add it all up, I think it comes to be J. That's a lot of time for one question. Anyway, so 35. That might be a good question to come back to, that one, the big telephone bill question. 35. The parallel sides of an isosceles trapezoid. So the isosceles trapezoid is a parallel side. Isosceles trapezoid has two sides that are congruent. Those are the legs. And these are the bases of the trapezoid. It's isosceles because the legs are the same. Base 1, base 2. The parallel sides are 10 feet and 16 feet. What is the distance in feet between the two sides? In other words, how far apart are these two sides? To do that, how are we going to do this? Well, I'm going to find out what this is, right? Okay, let's do that. Well, let's draw this one too. Okay, well, okay, very good. Okay, I did that. Oh, this is a right angle. So if this is 10 feet, this here is going to be 10 feet, right? From here to here, because I just made a rectangle. Yeah? I just made a pretend imaginary rectangle, right? So that's 10 feet. Well, how many is left? Okay, out of 16 feet, I have 6 feet left, right? Well, it's going to be equal here. So this is going to be 3 feet over here and 3 feet over here, right there. Okay, now I have a right triangle. Okay, this is 3 feet. That's 5 feet. How much is this? Well, that should be a no-brainer. I gotta tell you, that should really be a no-brainer. That is going to be 4 because this is a 3, 4, 5 right triangle, right? So how far apart are they? Well, there are 4 units apart, 4 feet apart, like that. Now, this is 3, 4, 5 triangle. You could also do Pythagorean theorem, right? A squared plus b squared equals c squared. Come on, but really, you gotta know 3, 4, 5 triangle. It's like a Pythagorean triplet, right? These are Pythagorean triplets. You gotta know Pythagorean triplets. Who are the Pythagorean triplets? Let's name them. 3, 4, 5. I mean, these, whenever a triangle that has these side measures, it's a right triangle. Okay, 3, 4, 5. Okay, 5, 12, 13. Okay, 7, 24, 25. 8, 15, 17. These are Pythagorean triplets or triples, okay? So if you have a triangle that's like this, right triangle, this is 3 and this is 5, that's a 4. That's a 3, 4, 5. And multiples of these. So 3, 4, 5 and multiply the whole thing by 2, you get 6, 8, 10. 6, 8, 10 is also a right triangle like that. So these are Pythagorean triples or triplets. You gotta know them. You gotta know them. 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. You gotta know them like you know your phone number, you know, or your zip code, you know. You have to know the Pythagorean triples. Okay? So, and while we are on a trapezoid, okay, an isosceles trapezoid, like this one, Okay, there are two things I just want to mention to you. Okay, so this is base 1 and this is base 2. Okay. All right. So then, if you connect the mid segment over here, okay, the mid segment of a trapezoid is a formula associated with that. It's going to be average of the bases. So they have a mid segment of trapezoid formula. Let me show you here. It's going to be average of the bases like this. So if you know this and if you know this, if you just add them up, take average, you get the formula. So if you want to find this side length, it's going to be average of this and this. So let's call this the mid segment. Mid segment means it connects the midpoints on the two sides. And the mid segment length is going to be the average of the two bases. Okay, this is one thing you got to know about the trapezoid. Okay? Alright, this is the height of the trapezoid, okay? The area of the trapezoid is going to be 1/2, okay, times height. Okay, the 1/2 base 1 plus base 2 times height, okay? Alright, so it's like the triangle because a trapezoid is kind of like a truncated trapezoid, right? A trapezoid is a truncated triangle. Okay, so that's the formula for area of a trapezoid is very similar. It's 1/2 the base 1 plus base 2 times height. Okay, now, so those are two things I just wanted to bring to your attention. The area of a trapezoid, while we are talking about it, this is of a trapezoid, and the mid-segment length of a trapezoid is the average of the bases. Now, a trapezoid, the definition of a trapezoid, it has only one pair of parallel lines. Okay, the legs, they don't have to be congruent, but if they are congruent, that's called an isosceles trapezoid, right? Okay, so there we have, that's the trapezoid question, 35. Let's go on to 36. Question number 36 says, the inequality, this, is equivalent to which of the following inequalities? Okay, well, let's see. Let's simplify this. 3 times the quantity x plus 2 is greater than 4 times the quantity x minus 3. 3x plus 6 is greater than 4x minus 12. Be careful with the negative signs. And then I subtract 3x from both sides like this. I get 6 is greater than x minus 12. I add 12 to both sides. I get this. Okay. Now, I can rewrite this. See, you can rewrite this as x is less than 18. Just make sure the pointy end is towards the x. So x is less than 18, right? And the mouth is towards the 18. The mouth is towards you. You have to flip the sign. So, which one is this equivalent? Here it is. Okay. 37. In the standard xy coordinate plane, the midpoint of AB, so you have some AB, okay? So this is A and this is B. That's the midpoint. The midpoint is 4, -3. A is located at 1, -5. That's A. If xy is the coordinates for B, so xy is actually B over here. What is the value of x plus y? So to find x plus y, you have to find what x, y, and x and y are first of all. This is a favorite question, it seems. Okay. If you're given 2 points, finding a midpoint is easy. But if you've given the midpoint and one of the points, you have to find the other point. Well, how did you get the midpoint anyway? Well, the midpoint, the x-coordinate of the midpoint, right, is the average of these two x's. So x plus 1 divided by 2, that's how you got the 4. That's how you got that 4, which is the midpoint. So then you solve for x, okay? So 8 multiplied both sides by 2 equals x plus 1. X is going to equal to 7. Now, how do we get this y coordinate at the midpoint? Okay, Well, the y-coordinate at the midpoint, similarly, was the average of the y values. So negative 5, which is a, plus the y value here, divided by 2 is what gave you negative 3. So negative 5 plus y is negative 6, okay? Y was negative 1, okay? So now you have x and y, but the question didn't ask for x and y. The question asked what's x plus y. Well, 7 plus negative 1 is 6. The answer is 6. C. For all x in the domain of this function, blah, this function is equivalent to, well, we have to go back to over here because it didn't come out very well. For all x in the domain of this function, okay, this function is equivalent to, okay, well, x plus 1 over x cubed minus x. Okay, let's rewrite this. So we have x plus 1 over x cubed minus x. So in other words, this thing is equivalent to what over here? Oh, well, what else can we do? Let's see if we can simplify this. Can we simplify this? Yes, we can. Yes, we can. So how are we going to simplify this? I don't know. But maybe we can factor out something here. Okay, well, let's see. Nothing to factor out there. Here, so you can factor out an x, because x is common to both. When you do that, you get x squared minus 1. Wow, what can I do now? That didn't help me very much. But wait, what can I factor out over here? Can I? Well, x plus 1 over there. Well, see, this is a special case. X squared minus 1. That's like a squared minus b squared. Well, a squared minus b squared was a plus b and a minus b. That's one of the special cases. Very important special cases. So you can factor this out, see, as x plus 1 and x minus 1. But now look what you have. You have x plus 1 at the top and x plus 1 at the bottom, right? So you can cancel these out. Then this becomes 1 over x times x minus 1. Let's see if one of these is any of the choices over here. 1 over x minus 1. There it is. Okay. So 1 over x squared minus x. That's that. Is there a choice in there? No. What I meant to do this here. That's not. Oops, daisy. So you know what I'm saying. It's this one here, j. 1 over x squared minus x, which is that. Okay? So that is the answer. So this is very important, actually. For example, x squared minus 16. How do you factor that? Well, that's a squared minus b squared. That factors into a plus b and a minus b, which means it's going to be x plus 4 and x minus 4. You got to get this. X squared minus 25. That factors into x plus 5 and x minus 5. Now watch this. 9x squared minus 36. Okay? This factor 3x plus 6. Okay? 3x minus 6. A squared. Do you follow? Very, very important. This is you have to know this. Okay? Alright. So we did that one. J. Number 39. Okay. Number 39 says, in the figure below there are 3 lines. Okay. There's T, U, L, M. Okay, very good. 4 lines. L is parallel to M. Okay, these two are parallel. Let's mark them. Okay. There are 2 transverses, T and U. Okay, they both intersect at point A. Okay, very nice. And all these points. Point X is on M. Okay. Let's go over here to something that makes sense. Okay. So it's like this, okay? And I like to undo this, excuse me. And the question here is, this is 130. 80. How many of the angles formed by these lines are measured 50? And how many 50-degree angles are there? Well, this question is not that difficult if you know everything that you need to know about parallel lines, okay? And if you don't know, then it's going to be a tough one. So watch. So if two parallel lines are cut by transverse, so see you have parallel lines. The only way you know if two lines are parallel if you're told that they're parallel, or if there's some other indication otherwise. Okay, but anyways, here we're told that these two lines are parallel. If two lines are parallel, now these angles are given names, right? Okay, let's talk about this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Angle 2 and angle 6 are very important. These are corresponding angles. Corresponding angles, right? Corresponding angles. Okay. Angle 3 and angle 6, these two. These are called alternate interior angles. Okay. Because everything inside the parallel line, those are interior angles. Everything outside here, those are exterior angles. So 1, 2, 7, 8 are exterior angles. 3, 4, 5, 6 are interior. 3 and 6 are alternate interior. 4 and 5 are alternate interior. Alternate interior here, alternate interior here. 1 and 8 are alternate exterior angles. Alternate on the other side, exterior angles. So 1 and 8 are alternate exterior angles. 2 and 7 are alternate exterior angles. 3 and 6 are alternate interior. And 4 and 5 are alternate interior angles. And finally, running out of colors here. Finally, this angle here, number 5 and number 3 on the same side are consecutive interior angles. Okay, consecutive interior angles. Okay? So you gotta know the names of these, right? And corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Okay. Once you know what they're called, then you gotta know a few things about them. And what you gotta know about them is the following. Okay. You have to know that the corresponding angles are congruent. So corresponding angles are congruent. And so alternate interior angles. Alternate interior angles are congruent if the lines are parallel. And so are alternate exterior angles. Everything is congruent, right? All except for consecutive interior angles, like 4 and 6. Consecutive interior angles, they are supplementary. See, they add up to 180 degrees. So alternate interior angles are congruent, alternate exterior congruent, corresponding angles are congruent, and finally, consecutive interior angles are supplementary. That you have to know. And then the basic stuff that I didn't mention, vertical angles are congruent. Now, what are vertical angles? Vertical angles are opposites, like this. Give me an example of vertical angle. Yes, that's correct. 1 and 4 are vertical angles. 2 and 3 are vertical angles. 5 and 8 are vertical angles. And 6 and 7 are vertical angles. These are supplementary too. They add up to 180 degrees. And so are these. They're supplementary. They add up to 180 degrees. Okay, so you gotta know that to be able to answer this question. Now we have this. This question is like this, okay? And this is what's given to us. This is 130 degrees and this is 80 degrees. That's given. Now, we asked how many 50-degree angles are there? Well, this is 130. This is 50. If that's 50, I know that's 50 because these are vertical angles, okay? And just for completeness sake, we just put this 100, it'll be 130 over here. Okay, now these are parallel lines. So we're given that those are parallel lines. That's very important. That's the only reason we can actually solve this question. Okay, now we're given that's 130, so this angle right here is going to be 50, see, because these are consecutive interior angles and they're supplementary. Okay, if that's 50, all right, and this is going to be 50, okay, because these are vertical angles. All right, now this is a triangle over here. All the interior angles of a triangle add up to 180. That's 80 plus 50 is 130. So this is going to be 50. That's 50. So this is going to be 50. Okay? That's because they're vertical angles. This is 50. That's going to be 130. That's going to be 130. They're supplementary. Now these two lines are parallel again. So this is 130. This is going to be 50. Okay, because those two are consecutive interior angles. Well, if that's 50, this is going to be 50 because they're vertical angles. Okay? Now we are ready to answer the question. This is going to be 80 over here. Now we know all the angles, see? Let's count how many 50 degrees. There's 1, there's 2, there's 3, there's 4. There's 5, there's 6, there's 7, there's 8. There are 8 angles, there are 50 degrees. And the answer, therefore, is 8. Okay. Alright, that's 39. Number 40. The tickets at a senior talent show at George Washington Carver High School. The tickets cost $3 for adults and $2 for students. To cover the expenses, a total of $600 must be collected from the ticket sales for the show. So they have to make at least that much money. If they make more than that, that's great. If they sell 1 billion tickets, it's good for them. One of the following graphs in the standard XY coordinate plane, which one of these, where X is the number of adult tickets and Y is the number of student tickets, represents all possible combination of ticket sales that cover at least this much expenses. Which graph is it? Well, this is what they're saying. It says $3 for adults and $2 for students. They have to make at least $600. X is the number of adult tickets they're going to sell. Y is the number of student tickets they're going to sell. The number of adult tickets they send plus the number of student tickets that they send has to be equal to, has to be greater than 600. They didn't say greater than equal to, but at least 600, right? That'll cover their expenses, at least. So which one of this graph? Well, this is the equation of the line in the standard form. That's ax plus by equals c. So you have, it's going to be a line. How do you graph this line? Well, the way you graph this, you can just need 2 points. You make the baby table like this, right? 0, 0. You need 2 points to graph this. When x is 0, what's y? Let's put 0 over here. 2 times x thinks is. That's y is going to be 300. When y is 0, okay, that simplifies to this. That's going to be 200. So now you have it. This is one ordered pair. This is the other ordered pair. When x is 0, y is 300. Which one of this is this? That's this one. Okay. Okay. And that's, and when x is 200, y is 0. So those are the two graphs that you're looking for. And this is h over here. So this graph, this ordered pair here is when x is 0, y is 300. This ordered pair over here is when x is 200, y is 0. So this is the graph that represents, this is an inequality that represents all the possible ticket combinations. Okay? So that's question number 40. Inshallah, after pause, we shall continue with question number 41. Until then, as-salatu was-salamu ala rasulillah, alhamdulillahi rabbil alameen. Assalamu alaikum.